name is Yarden Laifenfeld. I'm a software engineer at Rookout. I really love learning new programming languages, and in my day-to-day, I use a ton, mostly Go, Java, and Ruby, but also a little bit of C#, Python, JavaScript, and C++. So yeah, I love jumping between them. I love learning them, and also diving into their internals. And when I'm not next to a computer, I also like to sew. If you like to sew, if you like to sew as well, let's talk about it. So at Rookout, we're building what we call a debugger for production, something that allows you to dynamically add log lines to your code as it is running in production. And I love my job. I love my job not only because I think what we're doing is revolutionary and will help a lot of people or already is helping a lot of people, but also because I myself love debugging. I know it's kind of strange. A lot of people don't like debugging, and I only recently found this out about myself. But well, what I mean about that, what I mean by that is that I didn't find out that I love debugging. I've always loved debugging. I've always known this, but I kind of assumed everyone else also really likes debugging, and only recently I found out that people really, really don't like debugging. And when I found that out, I was actually called a great employee by my boss because I told him, keep giving me bugs. I want to do all the bugs. So I was quite confused, and then I started to realize that that was the truth. Everyone hated debugging, and I loved it. And I tried to figure out why. And so on this journey to figure out why, I dove into debugging techniques and what we do when we debug, how we plan it, all these kinds of things, and that's what this talk is based on. Now, let me take you back. 3 years ago, I was in the Army, and as part of my service, I taught or I instructed a course, just like students, new soldiers that had just finished high school, and they were learning basically from 0 to an entry-level position in the software developing world. So we taught them everything they need to know. You can kind of think of it like a boot camp on steroids, because in 3 months they had to sleep at the base for most of the weekday, and they were learning from 8 a.m. to 11 p.m. I was also there during that time. So in 3 months, we were really able to get them exactly where we wanted them, from no knowledge at all to an entry-level position, which is pretty cool. And as an instructor in the course, I had a lot of say over the syllabus, and I also gave some of the lectures myself, and in particular, I was responsible for the subject of learning C, the programming language. And what I realized is that out of 30 hours of lectures for C in the course, only one of them was for debugging. And even in that 1 hour, what we discussed is not how you should debug or how you should approach it. It was more like, this is a debugger. Here you can see your variables. This is how you do that. So more like use of the practical debugging tools and not debugging in general or our approach to it. This isn't specific to that course. If you've learned in university or taken online courses or boot camp or whatever, you've probably had about 1 out of 30 time to actually practice or learn about debugging. And this is not proportionate at all to the actual time we spend debugging. This is a totally made-up fact that we spend around 50% of our time debugging, but I did try to find an accurate number, and there were just a bunch of very, very differing numbers online, so I took 50%. This is on the low spectrum of the numbers that were given. There was one website that said 90% of our time is spent debugging. I think more than 10% of my time is waiting for code to deploy, so I'm not sure that's exactly true. But just think about it, right? Most of the time, even if we're writing features, we're stopping to debug on the way when we have like these little things that we forgot that we did accidentally. So we're debugging a lot. And then, so you might be asking yourself, why? If we debug so much, why don't we teach about it as much? And I think these are the 4 main reasons. The first is that we don't know how. If I'm trying to teach you about coding, I can tell you to do a for loop, you need this initiation sequence, and then you have a condition, and then you have a step. And it'll work every single time. No matter what you write in those 3 steps or 3 instructions, it'll happen the same way. Debugging is not like that. I can't tell you, oh, just comment out the problematic code each and every time and it'll always work, you'll always find your bug. So it's difficult to teach debugging, and we kind of just rather avoid it. The second thing is that debugging is a lot about intuition. Not only intuition in general about debugging, but also about the specific code base that we're talking about. So if you've debugged 5 bugs in your code base and they all stemmed from about the same area in the code, you'll know in the next bug to go ahead and search in that area of the code. And this intuition is something very, very important, and that will make the debugging process much easier and progress much faster. The third is that it's just not fun. When I say I love debugging, everyone's just like, oh my god, no you don't, stop. So, because they think debugging is not fun, and I understand that. And because of that thought, we don't want to teach it. Not only do we think debugging is not fun, it's not fun to admit our code isn't working. It's not fun to admit that we wrote something that is now broken, or that we don't understand what is happening in our own code. So why deal with it when we can just teach everything else that we do know how it works? And the last part is simple code equals simple bugs. When learning to code, we're learning simple programs. We're not writing thousands of lines of code. We have small servers that do small things, and in turn, they have small bugs. So for small bugs, we don't need full-on debugging techniques, and so we just don't learn them. And still, I'm standing in front of you today and talking about debugging and approaches to debugging. So I wanted to kind of give you my take on each of these 4 reasons. Well, the first is that I really don't know how. I'm not going to give you a surefire way to find your bug. There's no one-size-fits-all solution to debugging, but I am going to give you guidelines to find the biggest, meanest, toughest bug out there, and then you can take these guidelines and make them fit your specific situation. If it's a smaller bug, use some of the guidelines, use some of the techniques. If it's a bigger bug, use all of them. So just kind of fit it to your situation. Intuition, I can't help you with intuition, but I can say that if we debug with intention, so if you use the technique I'm going to show you, you're going to be debugging with intention, you're going to be thinking about the steps that you use while debugging, then you'll actually be able to fully experience it and be able to reflect back on what you did the next time you're debugging. So you still need to gain that intuition, but you're going to gain it faster than if you were just kind of an autopilot debugging your code. It's not fun. Well, I think it is fun. But I also think a big part of it's not fun is our attitude and our approach, right? If I come to a task, any task, not only debugging, with this pessimistic approach of this is going to be annoying, I hate looking at this code, I hate trying to fix bugs there, I hate trying to write code there, or I hate a certain programming language, why am I writing in it? Then the task is going to be annoying. It's going to be tough. It's going to be harder than necessary, and it's all because of our mindset. So I say kind of try with a fake it till you make it attitude, and eventually you don't have to fake it anymore. And it's just kind of nice, or even fun to debug. And the last point is that this is not a course to learn to code, so I will be talking about advanced bugs, and let's get to it. So let me start by saying that I'm going to be making many generalizations, and I'm going to be saying, you do this and you do that, and please don't get offended. I do not know what any one of you does. I'm just saying that because this is what I experience from the people around me, from I myself, how I do things, and this is generally correct. So this is kind of the flow we take when we're debugging a bug now. The first is unexpected behavior. The first step is unexpected behavior. We encounter something going wrong, and then we try to fix it. We say, what's happening, why is it happening, where is it happening, and then we implement the fix. So unexpected behavior doesn't necessarily mean a bug, right? It can just be incorrect use. Incorrect use could be, for instance, a UI UX issue, or maybe even a bad response. For instance, if a user clicks, don't click me, it's okay to respond, but you probably shouldn't crash their computer. So those are issues, but I don't know if we'd call it a bug that we need to deploy on a debugging technique on. The second type of unexpected behavior is something went terribly wrong. If you've ever seen this screen before, okay, this is a Linux conference, so this is the blue screen of death. Yeah. It doesn't mean necessarily something happened in your code. It just may be, you know, that 1 in a million bug that happens, and we just got to move on and deal with it. Third thing is integration issues. So if my part of the code works exactly as I expect it to, and your part of the code works exactly as you expect it to, but our communication isn't good enough, and I'm using the wrong protocol or sending you the wrong values, then we're going to have a bug, but the bug isn't going to be something that I need to find with a magnifying glass in my code. It's just going to include communication between us to solve it. And the last type is something that I'd really call a bug, which is when expectation just does not meet reality. So we expect our code to do something, and in practice it does something else, and we don't know why, we don't know what, and now we move on to the next step of trying to figure it out. So we'll do multiple things, right? We'll stare at the code, we'll read all the logs, maybe try to reproduce, run through each line of code with a debugger, comment out the problematic code, start adding random lines and seeing what's happening. Anything you do while debugging. And then you finally found it. So you found the bug. Now you need to find a way to fix it. You need to write the code that fixes it, and maybe add a test to make sure there's no regression. And then you're done, right? You found the bug. Great. Well, I want to say that this is sort of a research-based flow. And what I mean by that is during this whole flow, we weren't at once thinking, oh, I know this code. This is code I wrote. This is code friend from my team wrote. This code isn't a mystery. No, we're treating it as if it's a mystery, as if we need to find and look through the lines that who knows what they do, when in fact, our code is doing exactly what we told it to do. It's a harsh reality, but it's one we need to face if we want to use all our developer skills and all our knowledge of the code base when we're debugging. So once we kind of face that, we can't say that our code is a mystery anymore, because it's not. The second thing is that we haven't planned anything. We kind of just dove right in, try to see which part of the code was problematic, which part of the code this bug was stemming from, and we just did whatever we could to fix it. And the third thing is that we were guessing randomly. Maybe we didn't even know which flow caused the problem. Maybe the problem was this, but this is what caused it, and we were only looking here until we finally realized that, and then we took it all the way back here. We don't know, and we're guessing. We're probably print debugging. I have nothing against print debugging, but we're probably print debugging and just trying to figure out what's happening. So I say, let's approach debugging like writing a feature. When writing a feature, we have certainty. We love certainty. We love patterns and things that work exactly as we expect them to. If I go back to the for loop, we love that the for loop is the same. We love it so much so that in every language almost, you'll have the for keyword. We love it. And then when we get to debugging, it's all of a sudden all these uncertainties. Where is it coming from? What's happening in my code? Is this line the problematic one? Is this one? And I want to take away that uncertainty by planning it out more. I'll discuss the technique itself, but what I want you to remember is that we want to take the stress out of debugging. Debugging is still going to be debugging. It's still going to be finding a bug. We're still not going to know which part of our code is the problematic part, but we can be calm, and we can plan it out so that we're not stressed about it, so that we know what we're going to do, okay? We won't be certain about where the bug is, but we are going to be certain what our next step is going to be. So let's take a look at what we do when writing a feature. We'll have these three main big steps, which is specification, planning, and executing. Specification is going to include getting all the information, whether it's to understand the task itself, maybe talk to the product team, or to your customers, or whoever's going to be using this feature, and just understand what they want. Maybe you'll discuss some edge cases and what you should do if there's an error or something like that. Maybe you'll discuss protocols. If your program is going to be communicating with another program, what's the protocol there? And you're just going to get all the information that you need to fulfill this task. You're also going to need a definition of done. If this is a huge feature, you're probably going to have small definition of done for each little small part of the feature. So you're going to want a definition of done to be able to say, I did exactly this task. And that's before you even plan the task itself. But now we're at planning. So we're going to design the feature. This is like just designing code, right? We're going to say which components we want, which languages we're going to use, which design patterns, which third-party libraries, just anything that's going to involve your code in sort of a high level. And at this point, we usually don't do it ourselves, and we don't just go for one option. Especially if it's a bigger feature, you're going to say, I like this design and I like this design. You're going to think of a few options and maybe also talk to the people around you and talk to your boss and talk to whoever else is going to be working on this feature. And this is a step with a lot of options. And we'll also leave those options open, right? I mean, if we find out while coding that the design pattern that we chose isn't really going to work out, we'll just go back and choose a different one. So once we've designed the feature, we'll move on and we'll give ourselves deadlines, right? Deadlines for everything we do. So this is going to take this much time, this is going to take that much time. I'm not really here to talk about the deadlines, but more, what if I miss the deadline? So in my opinion, missing a deadline is a time to reflect. It's not a time to let go of your laptop and say, that's it, I'm done, whether I met the deadline or not. It's time to think, why didn't I meet that deadline? Is it because I didn't write the code fast enough? Maybe I should have just given myself more time. Is it because the task isn't defined well enough? Is it because the third-party library I wanted to use just too difficult? Just take a moment, reflect. Maybe this isn't the right design pattern at all to use. And then once you've reflected, once you've gotten to certain conclusions, you can continue working, maybe even on the same solution and just give yourself more time. Now, after we've given ourselves deadlines, we've planned it out, it's time to set up our workspace. And this still isn't part of the execution phase because we're just setting it up to start writing code before we're writing code. And I cannot emphasize this enough. We need an easy-to-run example. If you have to spin up 3 services on your computer and wait 10 seconds just to run the flow of your feature one time, that's going to make it tedious. It's going to make it annoying. You're not going to want to do it every single time. Think of it, okay? You're almost done with your feature. You had one small thing to add, and you did it, and you're there, you're going to run it for the last time, see that it works, and then you have to sit for 10 seconds waiting for it to happen. Yeah, not fun. You don't want that. So you want an easy-to-run example. In my opinion, if I need to click more than one button to cause my flow to run, that's not good enough. One button. I need to have up-to-date code, and I need to have a comfortable environment, both physically and digitally. And once I've done all 3 of these, I will write my feature and I will have fun with it. So executing is just writing code, right? We'll probably want to develop in iterations. I know that most of us kind of skip over that step. It's difficult to develop in iterations, but when we look at a really big feature, we still do it. And document as we code, whether it's in the code, right, documenting functions as we write them, or it's an external page to the code, we're going to document as and after we write. So these are the steps to writing a feature. And now it's time to debug a bug. And I'm going to take those same 3 big steps and show you how to debug a bug using them. Just as before, in the specification step, we're going to get all the information. We're going to ask ourselves, is it even a bug? If my computer crashed, does that mean that my program had a bug? Or that it just crashed because of some random thing that happened? If a user got a random error code, does that mean there was a bug or just a one-off kind of thing that it sucks that it happened, but it's not really a bug? So we're going to make sure that it is a bug. Then we're going to get all the information from logs, traces, metrics, anything you use to see what's happening inside your code. And you're going to maybe want to know which environment it runs on, right? Where is your code running? Which operating system? I don't know, anything about that. Once we got all the information, once again, we're going to have a definition of done. A definition of done is just the answer to the question, how do I know I fixed the bug? So if we can reproduce the bug, then it's pretty simple to say, okay, if this bug no longer happens in my reproduction, I fixed it. Reproduction isn't always possible, but you're still going to want to find an answer to the question, how do I know I fixed the bug? Okay? Great. Now, when writing a feature, we were designing the feature itself. But here we're going to design the debugging process. And that means that we're going to answer the question, If I wanted to purposefully create this bug, how would I do that? And this is very similar to where could this bug be, but the outlook is different. The outlook is saying, I know my code. I know what's happening. I know the components. I know the flow. Based on that knowledge, I'll say where I think the bug is. It's not going to be a where could it be. It's going to be a I know where it could be. And that makes all the difference. From the answer to that question, we're going to create multiple debugging vectors. So the answer could be pretty stupid, I guess you could say. Like, when I ask myself this question, the first thing that comes to mind is just like the most simple thing, and even things that aren't possible, right? Like if I'm adding an item to a list, it's not possible that I'm not adding the item to the list. But still, I'll write it down and I'll verify that assumption. I'll try out that debugging vector just to make sure that I'm not wrong. And also because sometimes the simplest solution is the right solution. I really get sidetracked easily. So even if I have like the sneaking suspicion that something might be wrong in a different part of the code, I'll just jump right to it and forget entirely what I was doing. So kind of planning it out ahead of time will stop me from doing that and will make sure that I'm on track with my current debugging vector. Now, saying debugging vector isn't enough. I need practical milestones. I need things that I can say, yes, I did them for sure. Okay, debugging vector is saying, oh, I'll check out this area of the code. But practical milestones is saying, oh, I'll run this test and make sure it passes, or I'll write this test and make sure it passes. Because that is something I can say, yes, I did for sure. Once again, we're going to have deadlines. This is something I really used to struggle with, which is giving deadlines for bugs, because I had no idea where I would find them. So, I start out in one part of the code, and then I'm jumping to another, and if I can't find it for weeks, then how would I know that ahead of time? But using those practical milestones, I can give each one of them a deadline. So I'm still not going to my boss and saying, listen, this will take me at max 2 hours. No, I'm saying, if this is what I think it is, my first option, it's going to take this much time. If it's not, it's going to take this much time, or maybe I'll come back to you and reevaluate. But I am giving a more concrete answer, and we can prioritize other tasks using these deadlines. Once again, we're going to ask, what if I miss the deadline? And it's the same exact answer. It's a time to reflect. It's a time to think about whether we're progressing in the right direction, if this debugging vector is really possible, or if I'm just guessing at straws. Maybe I should think of more practical milestones, and the milestone I gave myself was too big or too general. But it's just a time to reflect. Once again, we're going to set up our workspace. I put an emphasis on an easy-to-run example, because an easy-to-run example for a feature might be much easier than an easy-to-run example for a bug. Usually what happens is we'll have a bug. Let's say we got to some sort of reproduction with a bug. We're just going to run with that. We're not going to simplify the reproduction. We're not going to have it run really easily on our machine. And that's not good enough. That will make the whole experience tedious, because you're going to have to wait. You're going to have to run it remotely. You're going to have to do all these things. So before you start debugging, try to make it as simple as possible. Obviously, use the relevant code version and make a comfortable environment, both digitally and physically. In executing, we're going to have to choose the right tools to use. So as I said, I'm not against print debugging. I think it's a great tool. It's really easy to use. You already know what's happening. If there's race conditions, then print debugging is the best. Much easier than just using a debugger, which will actually stop our code. But if we actually want to know what's happening with all our variables and stuff like that, then maybe using a debugger is better. There's all sorts of debuggers. There are debuggers that will give you more control, and there are debuggers that will give you less control. Those that give you less control usually are easier to use, so maybe start out with those, and then if you see that's not enough, move on to those with more control. Maybe a profiler is what you need. Just make sure to think about which tool you're using and that it is the correct one to find your bug. Next, as we developed in iterations, we're going to debug in iterations. This is, again, back to those practical milestones. So we're going to take those practical milestones and just take each one separately and make sure we finish it before moving on to the next one. We're going to make sure we're making progress, that we're not just staring at the code. We can stare at the code. It's not bad to stare at the code, to read it, to understand it, to make sure it's exactly as we expected. That's not wrong. That's good. But staring at the code needs to come with a purpose. It needs to be, oh, I'm looking for this, or I'm validating this assumption. It can't just be, oh, maybe someday I'll find something here. That won't make us make progress. We're going to validate our assumptions. When we debug in iterations, when we debug small pieces of our code at a time, we can validate the assumptions we've made. So during this whole technique, we kind of assumed we know our code base. And that's the whole base for this talk, right? We know our code base, we should debugging based on that knowledge. But we still shouldn't take our assumptions for granted, and we still should validate them as we're looking at them. So don't jump between your code validating all your assumptions at once, but when you're looking at a specific part of your code, validate the assumptions that come with that specific part of your code. And the last thing here is super important, and that is commit to Git. If you're writing code that'll make, I don't know, a certain variable easier to print, or something in your code happen, a certain flow, maybe you've written the code for the one-click, easy-to-run example, commit that to Git. If there's a bug, again, in that area, you'll want to use that. If you, I don't know, start debugging one area and then finish with that and debug another, and then go back to the first area and committed to Git the easy way to debug that area, that'd be so much easier than just writing the code again. So commit to Git, super important. Git, it's a version control system. It'll be so much easier. Don't just like copy the code somewhere. Git is the best for this. Next, documenting. Document everything. It can be kind of annoying to document because you're like, oh, I remember this. I just did it. I won't forget it. But you will. Thanks. So document things that worked, document things that didn't, and document your thoughts. It's not enough to say, oh, I tried this and it didn't work. No, say why you tried it, what you expected to happen, why that didn't happen, and your conclusions. Because looking back, you'll say, oh, that didn't work, but wait, what was the error there? Why didn't that work? Maybe it was another part of my code that I already fixed the bug for, and that should work now. So you're going to be asking yourself all these questions, and if you document it, it'll help not only this debugging session, but every future debugging session for everyone who is ever going to look at that code base again. Last part here is document consistently and clearly, and I cannot emphasize consistently enough. When things are consistent, we can see patterns and we can read them more easily. It doesn't matter if you'd rather use a mind map or just like a table or Google Docs or whatever it is. Find what works for you and then use that forever. Because when you go back, you'll be like, oh, this is the same way I write today, and I understand exactly what I wrote there. And when other people, even if they have their own documenting techniques, once they get used to your documenting technique, they'll be able to read your documentation easily. And then finally, once you found your bug, you can fix it. And fixing it, I said right here that it is going back to the specification step, because it's going back to the specification step of writing a feature, because now we're writing code, and that's just like writing a feature. So, just a sec. So once again, these are all our steps. One after the other, we're going to do specification, which is exactly the same as when writing a feature. We're going to get all the information and have a definition of done. We're going to plan it out, which is design the debugging process, plan out what we're going to do, and then we're going to create deadlines, and we're going to set up a nice and easy workspace. And then we're just going to execute, we're going to use the right tools, we're going to debug in iterations, document everything, and finally, fix the bug. Now, this is a big caveat to everything I have said, and that is plan proportionately. If a user sends you a message and says, hey, I got this error code, don't jump into the specification stage. Look up that error code online. Okay, there's no reason to go through all of this for one small error code when you can just look it up online. So start off with a few of these steps, and if the bug is getting bigger and bigger and harder to find, do more of these steps. And so just try to make your debugging process proportionate to the size of the bug you're debugging. And finally, I want to see it in action. So we're going to have a program that is just a movie theater seat selection type of program. So the user will see something like this, and they'll be able to like click on certain seats and reserve them, and once they've reserved the seats they want, they can check out those seats. Please don't judge my design or my code or anything like that. I have never written code for a movie theater, and I don't ever plan on writing one. This is just for the example. So we're going to have a seats database that will have these 4 functions, which is get available seats, will return the available seats, reserve, which is just going to reserve the given seats. It's going to be associated with some sort of ID, so for the whole transaction we'll have some sort of ID. We'll have checkout with that same ID, so it'll just check out the seats that are already reserved with that ID, and we can just cancel all our reservations that are associated with a certain ID. So our seat selection flow, our seat selection flow is going to look something like this. We're going to have user cart. Once again, I do not know the correct terms for movie theater seating programs, but I call that user cart. So user cart will call db.reserve with the ID and the seats. The DB will check if seats are available. If not, it'll throw an error, and if they are available, it'll mark seats as reserved. Please note that reserve takes all the seats to reserve for that certain ID. So if there were previous seats associated with that ID, they will be discarded and they will be marked as available. And user cart adds seats to list of reserved seats. We like code. This is pseudocode. This is not in any language that will work ever. But in this case, we do need to serialize the seats in order to send them to the DB. And so we decided to do that in a different thread, just so that everything else can move quickly while we're reserving the seats. And so we just create a list with the new seat. We'll serialize that list. We'll try to reserve. And if reserve didn't throw an error, then we'll get to the last line and add that seat to our list of reserved seats. Pretty straightforward. Then we have a checkout seat flow, which we'll just call the db.checkout function. The DB will mark all reserved seats associated with that ID as taken, so no longer reserved but taken. And the user cart will send tickets for all the seats in its list of reserved seats, so it'll just look like this. We have db.checkout with that ID, and then we'll send tickets according to those seats. But we have a bug. And our bug is that Alice and Bob arrive at the movie theater with tickets for the same seat. Specifically, this is seat A3. And now we're going to take our debugging technique and use it for this bug. So the first step is get all the information. And in customer service, I used to be a waitress. So when I was a waiter, we had a saying, the customer is always right. So in software engineering, always doubt the user. That's kind of the, yeah. So we're going to doubt the user. We're going to make sure that these tickets are really for the same movie theater at the same time, for the same seat, that there really is a bug here. And after we've doubted the user, we'll find out that, yes, the bug does exist. It is really a bug. And then we're going to look at the logs, because the logs are what we have in this situation. So the logs are showing us that Bob reserved A2, Alice reserved A2, Bob reserved A3, Bob reserved A4, Alice reserved A3, Alice reserved A1, Alice tried to reserve seat A2, but it is already reserved to Bob, and then at the end, Alice checked out A3 and A1, and Bob checked out A4, A2, and A3. You don't have to remember that. The main part is those last 2 lines there where we can really see that Alice checked out A3 and Bob, too, checked out A3. So that's our bug. So we know it's real, we know there's a bug, and now we're trying to get our definition of done. We're going to try to reproduce. The way I would try to reproduce this is create 2 users and try to order 3 of the same tickets, or 3 tickets where some of them are the same. I'll tell you the answer, and that is that we successfully reproduced, and these are the logs that we saw. So we did see that once again, they both reserved or they both checked out with seat A3. So we have a reproduction. We know to answer the question, how will I know I fixed the bug, right? I know I'll fix the bug when this no longer happens. And now it's on to the planning step. So now I'll answer the question, if I wanted to purposefully create this bug, how would I do that? And in general, you can do this without looking at the flow of your code, because you know the flow of your code. But since we do not know the flow of this code, since we did not write it, by we I mean you, I did write it, then we're going to look at the flow while we answer this question. So I'm going to basically go point here and say what could go wrong, right? Well, if I wanted to purposefully add this bug, I could just make db_reserve not reserve seats. I could make db.reserve not do what it's supposed to do. Then again, I could make db just not throw the error that it's supposed to. And then the seats will be added, so it doesn't work correctly. Maybe user cart sends the wrong seats to reserve. Maybe I would do that. Maybe user cart doesn't add the seat to the list of reserved seats. I could do that, right? I could make it not add seats to the list. I could also make db.checkout not check out the correct seats. It could check out other seats, not the reserved ones. You see where this is going. So I kind of had this list that I created, which is that the reserve function doesn't work. We sent the reserve function the wrong seats. The db checkout function doesn't work, or that the db doesn't mark reserved seats as taken correctly, so that's something pretty specific in the checkout function. And maybe user cart just sends tickets for the wrong seats. So these are all just some very, very general assumptions. And now, first of all, we're going to prioritize them. In this case, I've prioritized them both by what is most probable, in my opinion, and what will take the least amount of time to check. So kind of thought about that, and then I got to this prioritization. I discarded some of the options just because I'm showing you this, and there's no need to talk about them. So the first one is that db doesn't mark reserved seats as taken correctly. So that means that in the checkout function, for some reason, something is wrong, and the db doesn't mark reserved seats as taken. Maybe it marks them as available, and then someone else can come and check them out as well. Next, we're going to say db doesn't check out the correct seats, and next is db_reserve doesn't reserve the seats. So now we're on to making practical milestones from those debugging vectors. And once again, practical milestones are something that I need to be able to say, yes, I did that. Yes, I did that, and for sure that's not the reason for my bug. So what I'm going to say about the first point here is to sanity check db.checkout. Sanity check, give them this input, and get that output, and it's pretty easy to say, yes, that worked, or no, that didn't work. And then maybe we're going to stress check it, send it a couple of times, do it with multiple threads, whatever, see if that worked. I also added a practical milestone for point 2, which was verify user chart and db mark the same seats as checkout. So again, something pretty easy to check, right? I can just print them out, see if they're the same. Now, I didn't add any more points because if they are the same, then that's it. We're done with that debugging vector. And if they're not, I'll just go back and rethink what are my next practical milestones. For the third one, I would also add practical milestones, but I didn't have enough place in this sheet, so I didn't do that. And then we're going to add deadlines. For instance, a sanity check, if that tester already exists, it's going to take me 2 minutes. A stress check, maybe it doesn't exist, but taking the sanity check and making it a stress check is going to be pretty easy. And then verifying that user cart and db mark the same seats at checkout is going to take me 10 minutes. It's not going to be long, but it is going to require me to look at the flow and look at the code and add a few lines. So given all of that, we're going to set up our workspace. Now, by now, we do have reproduction. First of all, we're going to want that reproduction in code. So if earlier I just signed up as 2 users and checked out the seats, now I'm going to want to use some API to do that and be able to run it in code. And also, maybe I want to minimize the number of seats. So maybe I want to try to reserve 1 seat from 2 users instead of 3 seats, just to simplify that. I'll spoil that for you. We would try to reserve 1 seat from 2 users, and the bug did not reproduce. So we're still going to stick with our 3 tickets and 3 tickets from 2 users. And obviously relevant code version and comfortable environment. Once again, just reminding you that these are our steps for executing. Since this is a fake code example, I'm not going to go over this step. We're not really going to be debugging it. I'm not going to use debugging tools or to debugging iterations, and I'm not going to document everything, but I do recommend that you do. And let's get right to it. So we checked the first two things, right? It took about 7 minutes as we'd predicted, and they both passed. So the sanity check passed, the stress check passed, and we can pretty surely say that db.checkout works as expected. And we're going to go ahead and do that third practical milestone, which was check that verify user cart and db mark the same seats at checkout. So we just added a print line in the checkout of both user cart and db, and we found out that user cart thinks we're checking out A1 and A3, while db thinks we're checking out only A3. So there's some sort of discrepancy there, something isn't synchronized. Now, we'll take it back, and we'll see that, once again, we're using our assumptions because we know the code. So we know that db.checkout checks out the seats that we've already reserved. So we can go back and say, OK, well, then something in our reservation process is wrong. And that's true. Something in our reservation process is wrong. Now, the bug itself isn't that interesting. If you want to, I'm going to upload these slides, and you can try it yourself. I'll also upload the solution to my Twitter, and not only the solution to the bug and what's actually happening there, but also the way that I would the way that I would solve it with my technique. By the way, you can totally debug it yourself with all the information in the slides here. You don't need any additional information. And that is how you use my technique. Now, I have one last thing to say, and that is have fun. I said it before, fake it till you make it. If you don't like debugging now, try approaching your next debugging session with a smile. Try thinking that it's going to be fun and that you're going to find it and it's going to be exciting. And think about that end rush, right? Even if you hate debugging, you've surely gotten that rush of, oh my God, I solved it, of, oh my God, I found it. So think about that when you start. You're going to have that. So kind of fuel yourself from that place of, this is going to be awesome. I'm going to find it and it's going to be fun. Thank you so much. Do we have time for questions? If anyone has any questions, you can also kind of reach me here. I'll be here. Oh.
Hi, thank you for sharing your experience on this. I just have a curiosity. What are your thoughts on commenting whatever you saw or whatever you went through? Like, let's say it's not obvious for the developer, right? So it's not about the coding itself, but it's all this experience that you went through. And let's say on this particular example that you say, like, let's say, for example, that the solution was adding a delay, for example, and you intentionally put a delay somewhere so that they don't get booked at the same time. Okay, let's assume that was the solution.
Okay.
And for somebody else just come to your code and then we say like, oh my God, what is this delay right here, right? Like, what are your thoughts on, after you add the solution, putting comments right there on the source code, like kind of giving an explanation on the source code after you went through? What is your, how do you see that? If you review your code, do you do these kind of things? Or?
So for sure, if there's a confusing line of code, then document that and say why you did that. I'm a low-level engineer, and so we have a lot of confusing lines in our code that I don't know why they're there, and so those lines just really save us from removing them, because when I see a confusing line, I remove it. So definitely comment that. Also, when I say document things, I also recommend on making those documentations like public internally in your company, just so that other people who will debug or look at those same areas of the code will be able to see that. So even you can add a comment of, this is needed for whatever, look at, and then just give a link to wherever you've documented even more into detail. Yep.
So a large focus of your talk was on knowing your code base.
Right.
There are a lot of times when you're working with code where you don't necessarily know the code base, or you know a piece of it, but a lot of the rest of it is just too big for any one person to understand. How would you recommend applying some of these techniques in a situation where either you're dealing with a bunch of old legacy code that everybody that knew how it worked has already left the company, or just the code base is way beyond the scope of one person's understanding?
So this is like a two-part answer. And the first is that this really does assume that you know your code, but it's more that you know the flow of the code. Like I never expect anyone to remember the lines of the code. And I would think that if you're debugging a specific part, you do know the flow in general. And you can also kind of, take this technique at a higher level at the beginning and say, oh, maybe this flow is the problematic one, and then just kind of like repeat it recursively until you get to a smaller part of the code. And the second part is that if you don't know your code base, like asking yourself where would I put it probably won't help you. So know your code base and then use this debugging technique. But I do think most of the other points stand, right? Like you can still plan it out and you can still kind of give yourself deadlines and all of those things, even if you don't know the code.
Any other questions?
Hi. Great talk. It occurred to me that I think there's a conceptual link with rubber duck debugging. You know what that is?
Uh-huh.
Because it's going to do the same thing. It forces you into a different headspace. But I never understood that till you mentioned that, and I realized that's true. And in fact, I think that they're going to work at the same time. Yours is more systematic, but it's almost like this is the next step. Okay, explaining it to somebody else who doesn't know wasn't enough. But I've already thought about the code, and I've already assembled some of the knowledge I need. So I thought that was really nice because it's kind of like, okay, there's an upgrade path when explaining it to the rubber duck wasn't enough. So it was more of a comment, but maybe you have some thoughts on whether that's right, and if you've seen people use them kind of where both of them get you into the headspace of thinking like you know the code instead of just it's a black box.
Well, that's interesting that you say that because I can't talk to my rubber duck. That's not in my, I can't do it. But I do use the Slack channel with my boss as a rubber duck. And I actually write out these questions. So how would I do it myself? I write that out to him. I'm just like, oh my God, how would I do this myself? Well, I could do this, and I could do this. And I totally agree with you. Like, for me, speaking my ideas out loud, make them make sense.
Yeah, I don't use the rubber duck because I don't care enough to explain it to the rubber duck. So what I do is exactly the same thing. I'll either write an email or a post somewhere on social media explaining the problem because then I have to be honest. And then I just never send it because I found my bug. So
that's great.
Someone, you had a question?
Where do you find is a good place to keep your documentation of your thought process when trying to debug?
I can't hear.
Where do you find is a good place to keep the documentation for your debugging thought process? Because it says document consistency during your debugging. Where do you find a good place to put that?
I use Notion. I love Notion. I think Notion allows me to represent my thoughts in the best way. And then I can just put a link to that in the standard documentation source that my company uses. I really think it's important to find what you like and not just use what is given or what everyone else around you is using, because that will actually make you maybe even maybe not excited to document, but it'll not make it as hard to do or as tough.
I have a question. Have you, with your experience, developed a template for documenting bug tracing, or so you can the developer ask you, how did you find this? Where you can say, oh, well, I followed this path, and how would you document that?
Yeah. Well, I have just folders of stuff, and I'll have I give my bugs titles, right? It's just oh, it's this bug. It can have a really stupid name, but it needs a name so that people can talk about it. And then under there, I really like tables because that kind of keeps everything organized for me. So I'll just have this is what I tried, maybe even copy the code there and see show this is the code that I tried. This is whether it worked or not, and this is my conclusions from that, and just make sure I have each of those columns for everything. And also, tables just force me to actually fill out all the columns for each row I write.
Yeah, the
Yeah.
steps.
So you mentioned getting addicted to the promise of the, yes, I found it. I am usually overcome by dread. What if I don't find it? What if I never find it? How do I, do you have any tips to talk yourself out of that?
Sure, yes. Actually, like, okay, so I'll admit that this whole talk, while it is part of like the debugging journey and trying to figure it out, the reason I wanted to talk about it is because I spent a few good months debugging one specific bug that we had. Yes, exactly, I was feeling that a lot. I was really exasperated, and first of all, I like talked to the people around me. Also, not only did I feel like I'll never find this, but I also felt like everyone around me is gonna be like, wait, all she's doing for months is just looking at one little bug, like what's wrong with her? Nothing was wrong with me. Something was wrong with the code. But, so first of all, talk to them, both because that will make them understand that you're not just staring at your code and just like helplessly, it'll make them understand, it'll make you more calm. And also, something that my boss kept telling me is that our code is 95% perfect, and that 5% is going to take as much time as the rest of the 95% took. And so, you know, I think it's a lot about, for me at least, it came from a lot of, from how people will perceive me if I can't finish this bug or find it out. And so that kind of really calmed me down because I said, okay, this is really the hardest part. Writing the code was easy, but finding out what's wrong is going to be harder. Thank you.
Any other questions?
Hi, thank you for your talk. You mentioned, I found it interesting, you said don't trust the user. What if you yourself are the user? Do you have any tips or tricks of getting past your own internal bias of saying, oh, my code that I wrote, it's perfect because I wrote it. I know I don't write bugs, but obviously we all write bugs.
Yeah, that's why I love this question of how would I do it? Because how would I do it is not admitting that you did something wrong, because you probably didn't do something wrong, like it's fine. We're all just writing code and hoping that it works. It makes sense that, you know, we may accidentally write incorrect code or that we didn't even realize that we're writing incorrect code, like it's fine, we all do it. But kind of taking the blame out of ourselves is saying, wait, if I wanted to do that, how would I do it? And then it's not like looking at it and saying, oh, where did I screw up? It's looking at it and saying, where would I screw up if I wanted to screw up? And really kind of taking the blame off yourself because it's okay, like everyone does that.
Thank you.
Yeah, but you kind of have to deal with it that your code is doing exactly what you told it to and you didn't write perfect code because no one does.
Maybe you're entomologist at heart.
What?
Yeah. First of all, going back 2 questions. Remember that you live in the open source world. All bugs are shallow. But I wanted to comment on one of your very first slides about the 4 reasons why people don't learn to debug. And I think there's actually a 5th, which is that debugging is assumed. You know, you start out writing your very first program, and you leave off the O, and your program prints out hell world, right? And so you go, oh, I made a little typo. And then as you go to write more and more complex programs, you sort of have to debug or they don't work. And so there's this very huge assumption, I think, that people are gonna learn to debug naturally, that they don't need help with technique because we've all been there.
Well, actually, when I was writing that slide and when I was thinking about it, I really think of teaching debugging like teaching design patterns, because this technique will fit on some bugs and doing certain things will fit on some bugs and not on others, just like design patterns.
Right.
And when teaching design patterns, you're just teaching a general technique. And when I was writing that slide, I was just like, if we teach design patterns and we're saying this is not a one-size-fits-all solution, why aren't we teaching debugging? And that's my answer to you, right? If we teach that, then we should still, like, we're
absolutely, absolutely. I'm not disagreeing with
Oh,
you
no.
at all. I'm just pointing out that there is an assumption that
Yeah.
everyone can debug.
Yeah, I think, but what I'm saying is that I think recently we've realized that we have a lot of assumptions about like advanced
Yes.
programmers, and so we're
Yes.
trying to debase those assumptions and still teach those advanced techniques like design patterns.
Exactly.
Yeah.
Hey, Yarden brought some stickers here
Yeah.
if you guys want. Free stickers, always good.
Thank you all for coming. I'm here if you want to ask any